Hey guys, Mr. Gucci here, and this video is to help you all with your mini lab, the Ionic cutout activity. Okay. So you have like 15, 17 of these problems you have to do. All right. I'm just going to start doing a bunch of them. I'm going to change them slightly so I'm not just giving you the answers. All right. And I'm not feeling very well. So I'm just going to jump around. I'm just going to do them until I just get tired of things. I'm just going to be like, oh, I've done like 10. I'm done. We'll see how far I go. Okay. So here's a sample, okay, of a problem: lithium ion and oxide. Now, the naming of this compound is simple. Okay. The naming is just the name of the first ion, then the name of the second ion. So the name of this compound is lithium oxide. Okay. Now the formula, we have to do a bit of work to figure it out. Okay. Lithium, I know, is +1. All right. I know this because I can go look on my Google Classroom. Okay. And to look on the Google Classroom that we have. Let's see here. We are period 5 classwork. Okay. Let's see here. Take a look. I uploaded this little chart here to help you out. Okay, so lithium we see is a 1 plus. It's the first column. So right here, what I'm going to do is I'm going to grab a 1 plus. Okay. Now oxide, I happen to know O is 2 minus. So I'm going to grab the 2 minus and I'm going to stick them together. Okay, I'm going to stick them together. Now, you might notice that as you stick them together, we haven't formed a perfect rectangle here, okay? Not really. We got a little empty spot here. So what do? We're going to have to grab another one of these lithium 1 pluses and slot it into place. All right? You keep doing this. You keep slotting in positive ions and negative ions until this happens, until you form a perfect rectangle where every little pointy side from a positive ion fits into a little negative space on these negative ions. Okay, so we've done it. So how many lithiums did we have? We had to use 1, 2 lithium. So the formula is Li2, and we had to use one of these oxygens, so just O1, or just O. Okay, now I'm going to have to make sure that I make this number here a subscript. Ins here, format, text, subscript. So there we go. That's the first one. Again, we're combining positive ions and negative ions in order to cancel out their charges. Let's try another one, okay? Copper 2 ions and nitride. Well, the naming is simple. Again, it's just the first one and then the second one. So the name is copper 2 nitride. Okay, that Roman numeral comes along with. Now, copper 2, that's real easy to know the charge. It's got that Roman numeral there. Copper 2 is a +2 charge. Let me pull it up. Nitride, however, is a 3 minus charge. Nitride is 3 minus. I'm going to grab a 3 minus. Now, I try and pair these things together here, and it doesn't quite work. Okay, it does not quite work. Figure you might mess some things up here as you're dragging. All right, you'll Control Z is your friend on this activity. Okay, so this doesn't work. There's an empty space. So I'm going to grab another copper and drag it into place. Okay, there we go. But now look, there's now another empty space. So I'm going to grab another 3 minus nitride and drag it in there. Okay, grab another 3 minus nitride and drag it in there. Okay, but once again, there's still an empty space. So what do I have to do? Well, what I have to do is I have to grab another 2 plus copper and slot it in. All right, bam, there we go. Okay, there we go. We got ourselves a rectangle. How many coppers did it take? It took 3 coppers. Let me just copy and paste this real quick. All right, yeah. All right, it took, that's a trick, by the way, here to like not have to keep doing like subscripts and stuff. So copper is Cu. How many coppers were there? 1, 2, 3. There were 3 coppers. All right. Nitride is just N. How many nitrides were there? There were 1, 2. So it's C3N2. That is copper 2 nitride. Okay. I added them together until their charge is canceled. Now we're going to get on to the ones that are your actual homework problems. Okay. Your actual lab assignments. Now I'm going to jump in here. So let's see. I'm having to do sodium ion and chloride. I am going to do, and let me pull up a periodic table on another page here so that I can use that as a reference. Okay, I'm going to do a calcium. I'm going to do calcium ion combined with sulfide. Okay, calcium ion combined with sulfide. All right, so the name again, the name is so easy on these things. It's the easiest thing, all right? No prefixes, none of that stuff. It's just the name of the first thing, which is calcium, followed by the name of the second thing, which is sulfide. All right, called calcium sulfide. So I look at this ionic charge here. Calcium, calcium, calcium is 2 plus. Calcium is 2 plus. So I'm going to grab a 2 plus guy. Okay. Sulfide, sulfide, sulfur 2 minus is 2 minus. Sulfide is 2 minus. So I'm going to grab a 2 minus here. I'm going to drag it in. And you know what? The charges cancel. All right. The calcium needed to give up 2 electrons. The sulfur needed to steal 2. It's a match made in heaven. So the formula is just CaS. All right. 1 calcium, 1 sulfur. That is calcium sulfide. Let's try another one. Okay, so aluminum ion and nitride. I'm not going to do that one. I'm going to do lead 4 and nitride. So the name of this thing is, well, it is lead, Roman numeral 4. The Roman numerals come along for the ride. Lead 4 nitride. Now, what is the formula for lead 4 nitride? Well, lead 4 has a, by definition, +4 charge. So I'm going to grab one of these guys, a +4. All right, great. Nitride is N3 minus. So nitride is a 3 minus. So I'm going to grab a 3 minus here. I'm going to click them into place. All right, bam. Now you see there's an opening here. All right, lead is trying to get rid of 4 electrons. This nitride's only accepting 3. So we got to bring along another nitride. Okay, another nitride in here. Good. But now there's openings here. This nitride is only getting 1 electron. It needs to get more. It needs 3. So we'll put another lead in here. Okay. Good. But now there's more openings. So I'm going to grab another nitride here and plug that into place. All right. But oh, look, even still more openings. You don't have to worry, by the way, don't worry about getting this lined up perfectly. Okay. So I'm going to get another guy right here and plug that in. Okay. Bam, bam, bam. Okay. Bing, bang, boom. All right. And then I'm going to grab another nitride to get this to all fit together. And there we go. We've got a rectangle. This is a bit of a tricky one. Okay. How many leads were there? By the way, lead is Pb. All right. How many leads did we use? We used 1, 2, 3 leads. And how many nitrides did we use? 1, 2, 3, 4 nitrides. So Pb3, N4. You just got to make sure that you highlight these things, go to format, text, subscript to turn them into the appropriate um, nomenclature, okay? To tell us how many different atoms there are, these are subscripts. These are little numbers down below. So Pb3, N4. Let's try another one, okay? Okay, cesium ions and oxide. How are they going to combine together? Well, the name, first of all, is just cesium oxide. I think you get the point, all right? The name is just the first guy and the second guy smashed together. Don't get creative here. Creativity is not your friend here, all right? Now let's figure out what are the charges of these guys. Cesium is +1. It's in that first column. So I'm going to grab myself a +1. Here we go. Okay. Oxide, we've worked with it previously on this sheet. It's a 2 minus. All right, so let's combine these together. Okay, not done yet. Not done. So I'm going to grab another one right here and plug it in. All right, here we go. Okay, there we go. It's balanced. Each of these cesiums are giving up an electron, and this oxide is going to need to accept both of them. So here we go. The formula here is CS2, that's the 2 cesiums, and then O1 for 1 oxygen. Now, by the way, if you write that O1 there, that's not the worst thing that happens, all right? Most scientists, in fact, pretty much I think every professional chemist would just leave it out. All right, like why bother? It's like an algebra class. Like you could say, oh, the answer is 1x. That's just the same as saying x. It's the exact same thing here. So CS2O, that is cesium oxide. By the way, guys, these are all real substances. Just go to Wikipedia and look up cesium oxide. Okay, cesium oxide. Okay, and what does it tell us? Here's the formula, name, uses. Cesium oxide is used in photocathodes to direct infrared signals. Okay, so this is used in infrared detectors. You probably have some in like your remote control, and it's used to like send and receive radio signals and infrared signals to your TV. All right, cool. These things are all real. Every single one you can look up, and they all have a uses section. Some of them are very useful. Some of them are not that useful at all, but they all exist. Okay, pretty much they all exist. All right, cool. Let's take a look at another one. Potassium oxide. Did I say potassium oxide? I meant iron 2 ions and carbide. Now the name is simple. All right, it's just iron 2 carbide. By the way, does this thing actually exist? Let me check. All right, iron 2 carbide. Does it have a iron? Iron. Okay. Yeah, iron carbide. Iron. Well, it's different iron carbide. There's many different irons. Remember, so there is no iron 2 carbide. But let's just run with this. Let's see what happens. Okay. So iron 2 carbide. Well, iron 2 is a 2 plus. Okay. And carbide is a 4 minus. All right, so once again, here we go. Going to combine these together. That's not enough, so I'm going to grab another 2 plus, put it down here. Bam, there we go. Charges cancel. The formula for iron 2 carbide is Fe2C1. All right, 2 irons, 1 carbon. 2 irons and 1 carbon. I'm just going to format, text, subscript, bam. So that's the formula for iron 2 carbide. There we go. And so forth. Let me run a few more with you here just to make sure you got a handle on this. Let me try another one. Aluminum sulfide. Okay. Now, aluminum is one of those metal ions that does not get a Roman numeral. So we have to look it up. Aluminum, Al, is a 3 plus ion. So here we go. Aluminum, 3 plus. Sulfide, I think we worked with it previously, is 2 minus. Okay, so let's see here. 3 plus and 2 minus. Not good enough. There's still an opening down there. Okay, let's try another one. Okay, well, now we got an opening down here, so we got to get another aluminum ion. Okay, now we got to get another. There we go. This works. All right, a little bit messy. All right, sorry if things don't line up perfectly. There we go. This is a balanced ionic compound, and it's made of 2 aluminums. Count them, 1, 2 aluminums you had to drag over there. So Al2, and it's made of 1, 2, 3 sulfides. So S3. Okay, let me go to format, text, subscript. Okay, format, text, subscript. By the way, the name of this, I skipped it. It's so easy. It's aluminum sulfide. Aluminum sulfide is the name of this ionic compound, made with 2 aluminums for every 3 sulfurs. And again, the reason why it does this is because every aluminum is trying to get rid of three electrons. Every aluminum is trying to get rid of 3 electrons. Every sulfur is trying to get 2 electrons. So you can't just put 1 and 1 together. The aluminum is trying to get rid of 1 more electron than the sulfur will take. So you got to add another sulfur in there to take that electron. But that sulfur wants a second electron, so you got to bring in another aluminum to donate it. But that aluminum has 2 more electrons after that it's trying to get rid of, so you need to bring in a sulfur that will accept them. All right? Aluminum sulfide will only form if you have 2 aluminums for every 3 sulfurs. Any more aluminums, and they're extra. They can't participate. Any extra sulfur, it's left over. It's not going to take part in the reaction. The reaction will always be 2 aluminums to every 3 sulfides. Does aluminum sulfide exist? Let's find out. Aluminum sulfide. Oh, they even got a picture of it. All right, yeah, Al2. This colorless species has an interesting structural chemistry. All right, yada yada, preparation references. I don't see any uses for it. Just say it's interesting. Okay. But I don't know. You can look it up. Maybe aluminum sulfide uses. Oh, let's take a look. Okay. So some of these compounds don't really have direct uses themselves, but they are important chemicals in reactions to create other substances that are useful. So aluminum sulfide doesn't really have many industrial uses itself, but it's used to make hydrogen sulfide, which is very important in chemistry. Okay, it's a strong acid used in a lot of different compounds. Okay, cool. All right, the more you know. Great, 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 great. All right, I'm gonna do one more, guys, and then we're gonna call it done for this. Okay, so here we go. Nickel 1 ion and phosphide. I'm gonna change that. Tin 2 ion and phosphide. The name, of course, is tin 2 phosphide. The formula is, let's grab a tin 2 phosphide, phosphide, phosphide is 3 minus. There's always going to be a plus and a minus, guys. Otherwise, they won't cancel out. All right. Okay. I'm going to grab this, bring this here. You'll get to a certain point, guys, where you won't even need to do this anymore. And that's when I know that I've won and I've taught you. And you'll know everything just by hearing the name and knowing the charges. Bam. There we go. All right. How many tins? 1, 2, 3. So SN3. And how many phosphides? 1, 2, P2. SN3, P2. All right. Format, text, subscript. All right. Format, text, subscript. Does tin 2 phosphide even exist? I don't know. Because sometimes a metal won't form a positive ion if it's reacting with a particular nonmetal. So let's see here. Tin 2. Does it have any uses? La, 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 la. I don't see any uses. Some of these maybe they don't have a use. What you gonna do? All right, guys. So that's it. So that is, practice questions for this lab. Good luck. Good luck, everyone. Good luck.